In the last 36 hours, we built Triple D, a three-step pipeline for countering fiber optic combat drones. In 2024, fiber optic suicide drones had killed soldiers who had every counter-drone system available. Every drone defense we have right now is built to stop radio, but when you take radio out of the picture, you're left with an unguardable killing machine. Suicide drones are what define close combat threat this decade. They're small, they're fast, they're cheap, and increasingly now, they're guided by a fiber optic cable instead of a radio link, which makes them basically invisible. There's no RF emission to detect, and there's no frequency to jam. The assumption of the multi-billion-dollar counter-drone industry right now is that drones talk over radio, and this completely shatters that assumption. Soldiers die because of this, and money is lost. So we need a completely different approach to countering drones in this modern warfare era. We need something that works when jamming is useless. Our solution is Triple D. It's ultimately a layered, non-kinetic, and edge AI defense system. This means it doesn't need GPS or an internet connection. And it stops enemy fiber optic drones through 3 steps. The first is detection. Instead of using radio frequency to detect a drone, as you usually will, it will use acoustic pitch of the propellers. Since the drone now needs to carry the weight of the mile-long fiber optic cable behind it, the propellers will be blasting at a higher pitch due to the higher power they need to propel the drone. We took advantage of this and used an acoustic sound pitch detector to detect drones based off sound. The third is decision. Once a drone is acoustically detected, a computer vision model is run based on our camera to detect whether a drone was actually there and whether or not it was friendly. To detect whether or not it is friendly, we are using a shared code between the drone computer, and our own computer. And if the drone does not share our code, it is flagged as an enemy drone, and the defeat or defend layer is now activated. This is done non-kinetically and in 2 ways. Number 1, a laser that is put behind the trajectory of the drone and is flashed to cut the fiber optic cable behind it. As a second layer of security, a decoy is also going to be put somewhere. A predefined decoy is going to be put somewhere that is in another location on the map. Whether or not this is another heat source to distract the drone, or a decoy tank or a decoy soldier somewhere else, this is completely up to the military. So here we have Triple D in action. On the right is a drone, and on the left is the Triple D robot. Essentially, what the Triple D robot is doing is, again, it's looking for a sound to detect. And then once this sound is paired with a visual confirmation of a drone, this robot will then flash an LED and follow the drone, signifying following the laser and using the LED, or the Mach laser in this case, to cut through it. So let's play that in action. Here, the drone comes up and the robot goes towards it with the LED flashing in the front. But when the drone is hidden from it, it stops moving and it stops following it. Here, it's trying to follow the fiber optic cable that's trailing behind the drone and attempting to simulate a laser cutting through the LED. Obviously, in the military, we'd have real lasers, but this is just a demonstration of how it would work. Additionally, there's an operator side view. This shows a view for the operator of our Triple D device and shows the whole 3D pipeline in action. From the acoustic detection being shown on the bottom right, on the bottom left, to the camera view upon the vision being activated, shown on the middle right, all the way to a 2D bird's eye view of the battlefield with the drone being represented as a node, as well as different decoys being activated. This is a mock demo of what it would look like in practice. So, as we can see, when something is detected, this is the view. We have the confidence score in the top right. We have the decision log in the bottom right, and we have the drone being shown as well as this decoy being activated in the top left. And when it returns back to normal with no detection, it will look like this with a cooldown before it. So yeah, thank you so much for listening, and I hope you like our project.